Hi, my name is Geraldo Iboa, and in this video we are going to cover artificial intelligence and machine learning. First, let's talk about AI. In a simple definition, AI can be defined as an intelligence that is artificial. So in other words, we can define AI as an intelligence that is performed by machine, not humans or animals. The human brains and animal brains can learn from past experience, and this is what we want our machine to do for us. For better understanding, I would like to give some examples to understand better what AI can do. First, speech recognition. Just like Siri, we want the computer to be like a human to understand what we are speaking to them. The second example is natural language processing. Every translation machine in this world uses AI to help them to translate a language. This technology helps the machine to understand a language just like a human brain. The next example is going to be about pattern recognition, where AI can help us to recognize patterns like stock price prediction, weather prediction, and so on. AI also helps robots to become smarter and smarter every day. The last example is computer vision, where AI helps the machine to see the world just like human eyes. So what is machine learning? Machine learning is a subset of artificial intelligence. And in this context, we want the machine to learn or study by itself. Let's assume we have an apple, a mango, and a pineapple. We will pass this data to the computer as a training data. The computer will need to learn that an apple is like this, a mango is like this, and a pineapple look like this. After the computer has learned by itself, we will give the computer a test data. Later on, the computer has to determine whether this fruit is an apple, a mango, or a pineapple. When we give this training data, we don't tell the computer that the apple is red, the mango and pineapple are yellow. We don't tell this data. We want the computer to learn by itself. So this is why we call the process as a machine learning process, because we want the computer to study by itself. There are three types of machine learning: a supervised machine learning, unsupervised machine learning, and a reinforcement machine learning. In terms of supervised machine learning, the human is supervising the computer in a machine learning process. In this type of learning, we already have the data with the label on it. If we consider the previous example, we already have the name of the fruit: an apple, a mango, and a pineapple. So we pass all this training data into the computer. And later on the computer has to guess what fruit is this. Next type of machine learning is unsupervised machine learning, where we are using clustering technique to cluster our data. We don't have the label of our data, so the computer can group our data based on the feature that the computer determined by itself. The final type of machine learning is reinforcement learning. Reinforcement learning is the training of machine learning models to make a sequence of decisions. This machine learning faces a game-like situation AI. The machine is given a cumulative reward if it successfully runs the game. In this particular video, we will be focusing on supervised learning. There are two types of supervised learning: classification and regression. We usually use classification for discrete output data, while we use regression for continuous output data. To further understand the difference between regression and classification, let's take a look at this example. So in this example, a regression model can be used to predict temperature for the next day, while a classification algorithm can determine the weather, whether it is cold or hot, according to the given temperature values. Next, this graph shows there's a lot of classification machine learning algorithms like decision trees, neural networks, naive Bayes, KNN, and SVM. The one that we are going to focus here is neural networks. Neural network uses some algorithms to recognize the relationship in a set of data through a process that mimics the way the human brain operates. In a sense, neural networks refers to a system of neurons, either organic or artificial in the nature, just like the human brains. There are so many types of neural network. The most famous ones are the 7 listed here. First, feedforward neural network, or the so-called artificial neural network, or ANN, is also called artificial neurons. This is the most basic neural network. Next, there's radial basis function neural network and coherent self-organizing neural network. The other neural networks are recurrent neural networks, or what we call with RNN, and long short-term memory, which is the improved version of RNN, and sometimes it is called LSTM. Next, there is a neural network that is specialized for image processing, which is called convolutional neural network. Last but not least is modular neural network. In this video, we are going to cover recurrent neural network, long short-term memory, convolutional neural network, and basic neural network, which is the feed-forward neural network, or the so-called ANN. This is the summary of our first part. We know that machine learning is a subset of AI. And machine learning itself, there are three types: supervised, unsupervised, and reinforcement machine learning. As for supervised machine learning, there are classification and regression. For classification, there are so many algorithms such as neural network, decision trees, naive Bayes, and SVM. And neural network algorithm itself has different types like feed-forward neural network, RNN, LSTM, CNN. These four neural networks are going to be covered in this video. Welcome to the second part of the video. In this video, we are going to predict a driver behavior based on driving data that we have using neural network algorithms. Before I get into this further, can you spot the differences between these two videos? I guess it's hard to determine which one is a normal driver and which one is an aggressive driver, because we only have like 5 seconds of video data. While a computer can determine which one is normal and which one is aggressive by using machine learning technology. Why do we have to recognize drivers' behavior? The answer is simple. Based on distributions of traffic accident statistics, most accidents happen due to personal factors, and this is very crucial that we have to implement a system or a driving auxiliaries to help the driver in order to increase safety. If we can recognize individuals' driver behavior, we can make the vehicle more personalized or more intelligent. The very first step in performing a machine learning algorithm is to prepare the data. Here we are going to prepare the driver dataset that we have obtained. Just for an interesting fact, 76% of data scientists say that the data preparation is the worst part of their job. And another interesting fact is that data scientists and data analysts report that 80% of their time is spent doing data preparation rather than analysis. And yes, in this project, I found that the hardest thing and the most complicated thing to do is to clean the data to be ready for machine learning algorithm. So first, in order to get the driver dataset, we have to download the UAH DriveSet from the internet. So big credits to the provider of UAH DriveSet. I downloaded from the internet. The UAH DriveSet data itself was obtained from a smartphone app called DriveSafe, where the drivers were required to mount their phone on their vehicle to record the urban environment. The UAH DriveSet consists of driving data from 6 drivers in different cars. Each driver was asked to drive in a normal, aggressive, and drowsy condition. So in the dataset, we have the driving data and the output of the data, which is either it is normal, drowsy, or aggressive. After we have downloaded the data, we have to discover, assess, and load the data. Here I'm using Python as a programming language and I'm using Jupyter as the IDE. I'm going to show you around the data of the driving data. The 6 drivers are separated into 6 folders. In each folder there are different driving conditions, which there are 7 driving conditions for each folder. In each driving condition folder, there are 9 text files containing the driving data. Let's take a look at one example of the file. Now, it is very complex to understand this data, so therefore, it is a good start if we make a parameters list so we understand what the data represents. The final step to do is to load the data using Python programming language or Jupyter as our IDE. Now we can move on to the second step, which is the data preparation. The first thing to do is to clean and validate the data. So different files have different number of columns, and what we have to do is we have to remove excess data, and also we have to merge the data so that every data have the same number of columns. We also have to filling in missing values, and now we have to make sure that all the data are in the correct order. In the UAH DriveSet, there are some data that is not in a correct order based on the time. So therefore we have to sort the data so that it is in a correct order. Last but not least is masking private or sensitive data. And this is optional, but it is recommended if you are working with private or sensitive data. The last step that we have to do is to transform, enrich, and store the data. First, we have to transform to the desired data frame. We have to make our data in a table so that we have the number of columns and rows that we want. The next thing is we have to enrich the data by encoding words, because we know that computer understand numbers more than words. So therefore we have to encode words into codes or numbers. Lastly, we can store the new data frame into a new .csv file so that later on we can use this new .csv file that has been cleaned for our programming, for our codes in Python. Now we have come to the final part for our preparation. It is the final preparation for machine learning and the machine learning process itself. This part will involve a lot of programming codes, with Python and with Jupyter as our IDE. In this video, we are not going to cover the complete codes. The complete programming codes will be covered in another video in another episode. The first thing we have to do is we have to load the libraries. Some important libraries are NumPy, which are for arrays, math for any math function or calculations, pandas for data frame, datetime for date, and keras or TensorFlow for the machine learning algorithm. And lastly, matplotlib for plotting graphs. First, we have to load the data. And this is the code for loading the data using pandas.read CSV. So this is our input data with a shape of 30,929 columns and 34 rows for our input data. As for our output data, we have 30,929 columns and 1 row, which is the behavior of the driver. Next thing we have to do is that we have to encode our words. This step is required if you haven't done so in the data preparation part. So you have to change words into numbers by encoding it using encoder. The next thing we have to do is to scale our data between 0 and 1. So we have to rescale our data in order for the machine learning process to not process a number that is too large. It is always better to process small numbers like from 0 to 1. So therefore we have to use min-max scalar function to rescale our data between 0 and 1, just like in the picture on the right hand side. The next thing we have to do is to reshaping X, or in this case X is the input data. We want to reshape it into 30,929 columns and then 1 column and then 34 rows. So now its columns are separated. Then we also have to split our training and test data. Here we set 80% of our data for training and 20% of our data for testing. So Xtrain is the training input, Ytrain is the output training, Xtest is the input testing, Ytest is the output testing. And the Xtrain shape is 24,743 columns. The Xtest shape has 6,183 columns. The Ytest shape 6,183 columns, and Ytrain shape 24,743 columns. The training data will be for the computer to train its algorithm, and 20% testing data will be for the computer to test its accuracy in predicting the driver's behavior. The next thing we have to do is that we have to model the algorithm. Different neural network algorithms have different ways of coding and have different name of functions. And we have to set the parameters that is required by its algorithm, like the number of layers, epochs, optimizer, activation functions, and others. Finally, we can run and predict the model. First, we have to compile, we have to fit the model, and we have to set the epochs. Usually, more epochs means more accurate. But if epochs is too large, then the waiting time is too long. After the model has been running, we make the predictions. Last thing we have to do is evaluation and tuning. So after getting the prediction, we have to evaluate the prediction, the testing accuracy, and the testing accuracy. Then what we can do is to analyze the error. After analyzing the error, we can do a thing that we call with hyper-tuning, or it means we tune like the batch size, the epochs, number of layers, number of neurons, activation functions, optimizer. So after getting the error and you know what is the problem, you can tune the parameters in order to reduce the error and hence increase the accuracy. Now I would like to share the results of my neural networks machine learning algorithms that I have applied in Python using Jupyter IDE. The result is not maximum yet as I haven't hyper-tuned my models. For multi-layer perceptron classifier or the ANN, this is the basic neural network algorithm. I got an accuracy of 96.7%. As for convolutional neural network, I got an accuracy of 90.93%. For recurrent neural network, I got an accuracy of 86.7%. And for our long short-term memory, I got an accuracy of 90.93%. Now there are still things to improve. We need to understand the error and we need to study the error, but before studying the error, first we have to understand the algorithms deeply. And then we have to understand what causes the error. After we understand what causes the error, we have to model the error so that we understand what steps should we take to reduce the error and what could be improved. For these machine learning models, we can also build a graphical user interface or GUI in order to make our machine learning software more user-friendly. Lastly, we can also combine machine learning algorithms. These algorithms are usually called ensemble learning. However, ensemble learning does not always guarantee the best result. I would like to end my video with these figures. Notice that all companies around the world have used artificial intelligence in helping to grow their companies. It is almost used in every industrial sector, and it revolutionized our industry. If we don't want to be left behind, then I think it is crucial for us to understand artificial intelligence, machine learning, and deep learning, as it is crucial to shape our future using data. Thanks for watching. I hope you like this video. Don't forget to like and subscribe. Thank you.